In this video, we are going to learn about Erlang distribution. The Erlang distribution is a generalization of the exponential distribution. So here, if the shape parameter k is 1, where you can refer this in the formula, I will explain this later. The distribution is the same as the exponential distribution. Since it is related to the exponential and we know the exponential is related to the Poisson, let's see what is the difference between Poisson, exponential, and also Erlang distribution. So Poisson distribution, refers to the number. This distribution, refers to the number of cars passing a toll gate in 1 hour. So this is our focus. In 1 hour, how many cars pass toll a gate? So for a Poisson, in general, it is events per single unit of time. And for exponential, we want to find the number of hours between car arrivals. Given that within 1 hour, for example, not within 1 hour, within the arrivals of still waiting up until receiving one arrival from the car. So that is exponential. So what is the time taken for a car arrive at a toll? So for exponential, it is a time interval per single event. Now for Erlang, it is the number of hours between the k cars arrival. For example, in the toll, we have the first car arrived. And then second car, third car, fourth car. So for waiting for the first car to arrive, so we assume this, let's say for the T1, where T1 refers to the time taken for the first car arrive. This one refers to the T2 refers to the time for car to arrive. Then this one third car arrive, and this one fourth car arrive. And let's say this is the kth. So this is the kth time to arrive. So this is Erlang. Where we want to know the time interval between any event and the kth following event. So suppose that a random variable x denotes the distance between k successive events of a Poisson process with mean lambda. Then we can say the x, that the random variable x is an Erlang random variable given the parameter is lambda. Where we can write it as x follows Erlang lambda. And this is the probability density function for Erlang, lambda to the power of k, x to the power of k minus 1, e to the power of negative lambda x over k minus 1 factorial. Given that x is greater than 0 and k equals to 1 up until infinity. So that's integrating the fx with respect to x, we can simplify that. The probability of x greater than x would be the summation of exponential negative lambda x times with lambda x to the power of k over k factorial, where k start from 0 up until k minus 1. So the mean for the Erlang would be k over lambda, and variance is k over lambda square. So now let's try this example. The failure of the CPU of large computer systems are often modeled as a Poisson process. So typically, failures are not caused by components wearing out, but by more random failures at the large number of semiconductor circuits in the time. So assume that the mean number of failures per hour is 0.01, and we let x denote the time until 4 failures occur in a system. So we want to determine the probability that x exceeds 40,000 hours. So how can we solve this? So the failure of the CPU model as Poisson process, and given the random variable x is the time until 4 failures occur in a system. So let me just rewrite this. So x is given as the time until 4 failure occurs in a system. Okay, so we need to find the x exceed 40,000, meaning that the time exceed 40,000 where 4 failure occur. And here we have this lambda, okay, the mean number of failure per hour is this value. So lambda is defined as 0.0001. Okay, where given this is in per hour. Okay, meaning that 0.0001 equals to 1 hour. Okay, so now we want to find the probability that x, okay, given x is the time until 4 failure occur, okay, exceed 40,000. So we want to find this x greater than 40,000. So until 4 failure occurs, meaning that if I illustrate this, okay, so this one never happened, failure had never happened. Okay, this one is the first failure, second failure, and the third failure. So x exceed 40,000, meaning that when the four failure happen, it's already exceed 40,000. Hours. Okay, so if we so meaning that, okay, from this situation, meaning that, okay, if we define n is the number of failure in 40,000 hours, okay, in 40,000 hours. So here, if because 4 failure happen exceed 40,000, so this one is our 40,000 hours. Okay, meaning that, okay, number of failure, okay, in 40,000 would be equals to 3 lah. Okay, within this, in this 40,000 hours would be 3. So we can also define this, our x, in terms of number of failure in 40,000. Okay, so I just rewrite. So the time until 4 failure occur exceed 40,000 hours if and only if the number of failure is 3 or less. Okay, so if you refer to this, you will understand what I'm saying. Okay, so now we can represent, okay, our probability that x greater than 40,000 is also equivalent to the probability of number of failure, okay, number of failure which is less than 3 in 40,000 hours. Okay, so since n is number of failure in 40,000, meaning that this is the number of successive events in interval of time, okay, where this n, okay, follows Poisson. So we need to find what is our lambda for this Poisson. So to find lambda, where lambda is the so n is the number of failure in 40,000, given that the rate, okay, lambda here is per hour. So we need to find in 40,000, meaning that we will multiply, okay, this rate in 1 hour with 40,000. So you will get your lambda, which is equals to 4. Okay, so our lambda would be 4, given that 0.0001 times with 40,000, which is equals to 4 failure over per, okay, 40,000 hours. Okay, now since we know the lambda, we can use the formula of Poisson. Okay, given that, okay, for Poisson, because we want to find n less than 3, meaning that we have to find from n equals to 0, n equals to 1, n equals to 2, n equals to 3. Okay, so I will just write it as a summation, okay, of the formula for finding Poisson, e to the power of negative lambda, lambda to the power of x, given x is 3. X depend on this lah, okay, where your k would be from 0 up until 3. Okay, 4 to the power of k over k factorial. Okay, where first k equals to 0, and then plus with when k equals to 1, plus with k equals to 2, plus with k equals to 3. So I forgot to put this px greater than 40,000, where it is also equivalent to n less than equals to 3, which is equals to this formula. Okay, so if we substitute the value for k, for all k equals to 0, 1, 2, 3, the summation of this will be 0.433. Okay, so this is the end of the video.